Good afternoon. Just looking into what we have been working with concerning functions, and most recently working with equations in two variables, namely x and y. And most recently we've been looking into parallel and perpendicular lines, and just sort of continuing with that particular range of topics. And we have on page 176. Okay, now we're looking at, again, various types of equations in two variables, and among the most recent items, okay, we've had the point-slope equation as well as the slope-intercept form of a linear equation. And in the case of number 6, now we're looking at establishing the slope-intercept equation of a line that has the following characteristics. Okay, and one, okay, we have the point through which this line is going to pass is going to be 4, -6. Okay, so we can designate the ordered pair x01, y01 as 4, -6. And the other key bit of information is the slope, and that is given as 3. Okay, so we have the slope m is equal to 3. Okay, so we have x1, y1, and the slope m is equal to 3. And looking at establishing the slope-intercept equation of the line that has these characteristics, we can start out by setting up the point-slope formula pathway. And again, we have for the point-slope algorithm, okay, we have y minus y01 is equal to the slope m times the quantity of x minus x01. And so we have the tools available where we can completely substitute. Okay, so we have for y minus y01, okay, so we're going to have y minus -6. And we have is equal to the slope m, which we have at 3. And we have times the quantity of x minus x01, where we have x minus 4. Okay. And undoing the double negative on the left, okay, so we have y plus 6 equals 3 times, okay, the quantity of x minus 4. Okay. And so for what we have at this particular stage, again, we have the point-slope equation for that particular line. And looking at following through and putting in terms of the slope-intercept. Okay, so we have resuming, okay, and going past the point-slope equation stage, okay, we can distribute 3 over the quantity of x minus 4, so we'll come out to the binomial 3x minus 12. And getting the y term by itself, okay, so we can subtract 6 from both sides. And now with y by itself, okay, this can be equal to 3x, and we have minus 12 minus 6 is going to end up at minus 18. Okay. And so we're going to have here this resulting slope-intercept equation. And you can always go back and check. Okay, so again, we have y by itself, and the coefficient next to x is 3, which is the slope. And I can test out for -6. So you have -6 for y, 4 for x. So left-hand side of the equation, which we have at y, we have the value to be at -6. And we want the value of the right-hand side of the equation to be the same. Okay, so here we have 3 times 4 is 12. 12 minus 18 is also -6. So we have consistency throughout. All right, now, for what we have in the case of number 12, and we have for this item, okay, we're looking also at the slope-intercept equation. Now, instead of having the slope and a point provided, we have 2 points instead laid out. And the 2 points through which this line is going to pass Okay, we have it negative 4, 8. And negative 7, negative 3. And just looking at what we have here. So we don't have the slope given, but I have enough information where I can establish the slope. And just keep in mind that all ordered pairs are of the form xy. So we'll just say negative 4, 8b, the first point. So we have negative 4 for x01, 8 for y01, and for negative 7, negative 3. Okay, so those will be the second x and y values. And so for the slope m, we're going to have change in y with respect to change in m. So we have y of 2 minus y of 1 all over x of 2 minus x of 1, and we have just filling in the values. Okay, so for y of 2 minus y of 1, okay, with what we have designated, okay, so y of 2 is at negative 3, and we have subtracting y of 1, okay, so we'll subtract 8 for x of 2 minus x of 1, so we have x of 2 is at negative 7. We're not subtracting, now we have subtracting x of 1, which we have at negative 4. And so we have at the top, we have negative 3 minus 8 to become negative 11. For what we have in the denominator, okay, so we have negative 7 and minus negative 4. We can translate the double negative to addition of the positive. So we had negative 7 plus 4. So this will come out to negative 3. So for the slope, okay, we have a negative over negative is a positive, and after undoing the negatives, okay, we have the slope in simplest form at the fraction 11/3. Alright, now for what we have in terms of creating a route to the slope intercept form, okay, we can establish things to get things set up in accordance with the point slope formula. And you can choose either negative 4, 8 or negative 7, negative 3. Okay, for that ordered pair. In the point slope equation. Again, you can go with either one, and so we'll go with negative 4, 8, but you could choose the other ordered pair. Alright, so again, just going back to what we have with the point slope formula. Okay, so you have y minus y of 1 is equal to the slope m times the quantity of x minus x of 1. And just filling in and substitute. Okay, so y minus y of 1. So in this case, by choosing negative 4, 8, so negative 4 is going to be the x of 1, and 8 is going to be the y of 1. And again, the slope we have just established at 11/3. And for x minus x of 1, so we're going to have x minus negative 4. And just undoing the double negative at the end. So y minus 8 is equal to 11/3 times the quantity of x plus 4. Okay, and so we have at this stage, okay, that is going to be the point slope equation. And we have in terms of the follow through. Okay. All right, so looking at distributing on the right hand side, so we have y minus 8, and we have is equal to, now we got 11/3 over the quantity of x plus 4, so this will be 11/3 of x, and we have plus 44/3 and looking at isolating the y. Okay, so we can add 8 to both sides. And for what we have now, okay, so we got y is equal to 11/3 of x. Now for the constants, we have 44/3 and 8. And just sort of moving to the side, okay, so you have 44/3 plus 8. And you can just write this as 8/1. And to be able to combine these ratios, I'll just write 8 in terms of thirds. And so multiplying 8 or 8/1 by 1 in the form of 3/3. Okay, so 8 is going to be 24/3. And so this is going to come out to 68/3. All right. So we have, in the case of the slope-intercept equation, we have y is equal to 11/3 of x plus 68/3. And this problem, that is going to be the, once again, the slope-intercept equation. And just looking at what we have, once again, okay, so I can test out, okay, so with, if I have y at 8 and x at -4, left-hand side is at 8, and to the right I have 11/3 times -4 is going to be -44/3. In turn, -44/3 plus 68/3. Okay, you have -44 plus 68 is 24. 24 divided by 3 is at 8. Okay, so you have that consistency. And if I were to test -7 and -3, left-hand side of the equation we have y at -3, and with x at -7, we have 11/3 times -7. So you have 11 times -7 is -77/3, added to 68/3. So you got -77 plus 68 is going to be -9. -9 divided by 3 comes out to -3. Okay, so -3 is equal to itself. So both of these ordered pairs do check out regarding this slope-intercept equation. So this will be your final answer. All right. Now, for what we have in the case of characteristics of parallel and perpendicular lines, and we're looking at just determining the slope. And for what we have here, okay, in the case of number 23, okay, so you have for the given line slope, okay, we had that the value is going to be at 3/11. All right, and okay, so you have the given slope at 3/11. Now for the slope of the parallel line, again, parallel lines are going to have the same slope. So one line has a slope of 3/11. So guess what? A parallel line is going to have the very same thing. So here we have the slope is equal to 3/11. And as for the perpendicular line slope, okay, so we're not going to have the same slope. And again, for perpendicular lines, okay, the slope values will have opposite sign reciprocal relations. And so for the perpendicular, okay, compared with 3/11, okay, so you're going from a positive for the given to a negative for the perpendicular. Furthermore, we're taking the reciprocal of 3/11, which in this case is going to be 11/3. So the slope of the perpendicular line comes out to negative 11/3. And just keep in mind, the product of the slopes perpendicular lines will be negative 1. So you got 3/11 times negative 11/3. And you have like negative 33 over 33. And so that is at negative 1. All right. And for what we have regarding next case, and for number 26, okay, we have the given slope to be at negative 10. And once again, looking for the slope of the parallel line as well as the perpendicular. Okay. So for the slope of the parallel line, again, if the given line has a slope of negative 10, well, the parallel line is going to have the same slope. So we have the slope at negative 10 also. And for the perpendicular line, okay, so this time, before we went from a positive to a negative, now we're going in the other direction. Okay, the given line slope was a negative value, but now for the perpendicular, this is going to be a positive reciprocal of 10, and so the reciprocal of 10, or the reciprocal of 10 over 1, is going to come out to 1/10. So that'll be the slope of the perpendicular. And again, product of the slopes perpendicular lines will be at negative 1. So you have negative 10 times 1/10. Negative 10 times 1 is negative 10 divided by 10. And so again, the product of the slopes is negative 1. All right. Now, looking at identifying the type of relation that can exist between lines in accordance with how the equations are laid out and what will lead to their slope values as the final determining characteristic if the lines are like parallel, perpendicular, or neither. We have 432. Okay, we have a couple of lines, and the first line is represented by the equation where we have 2x plus 3y is equal to 7, and where we had the second line to be represented by the equation where we have 4x is equal to negative 6y plus 2 and we'll translate these equations in terms of the slope intercept form. Okay, so we've got 2x plus 3y is equal to 7, and if we get the y term by itself, okay, so I can take 2x and subtract on both sides. So we have, after this stage, okay, we have 3y is equal to negative 2x plus 7 and getting in terms of y, so we have a division by 3. Okay, so you have 3y over 3 becomes y. And we have that y is equal to negative 2/3 of x plus 7/3. All right, so we have for the x term coefficient, okay, that is going to be the slope for the first line. And for the second line, okay, so you have 4x is equal to negative 6y plus 2. Now we have the y term on the right hand side, and I'll make adjustments to get y on the left hand side, but for what we have in the meantime, okay, I'm going to isolate the negative 6y by taking 2 away from both sides. So we have 4x minus 2 is equal to negative 6y. And then we have dividing by negative 6. Okay, so you got 4 over negative 6 times x. Now 4 over negative 6. Now we've got a negative ratio, and 4/6 is reducible to 2/3. Okay, so you have negative 2/3 of x. Now we got minus 2 over negative 6. And so that's going to translate to positive 2 over 6, which will be positive 1/3. And we have negative 6y over negative 6 becomes y. And just rewriting, okay, just rearranging, like going from b is equal to a is equal to b form. So we have y is equal to negative 2/3 of x plus 1/3. And so we have here the slope also at negative 2/3. Now the lines are different from each other. Okay, now we got y, we got the same slope, different y-intercepts, and since the lines are distinct, and since we had the same slope, and it's going to turn out that the type of relation that exists between these lines, okay, so lines that are different but that had the exact same slope, okay, those are going to be parallel lines. Okay, now looking at establishing, okay, equations for parallel and perpendicular lines. I know that 39 and 40 we're asking for just a perpendicular, but I thought that I would add the parallels also. Now, in 39, we have a given line, and this is defined, okay, by the equation whereupon we have x minus 5y is equal to 1. And to be able to establish like the parallel and the perpendicular lines, we want to go ahead and get the slope of the given line. So we have for x minus 5y is equal to 1. So again, if I get the y term by itself, so I can take x away from both sides. Okay, so I have negative 5y is equal to negative x plus 1. And then taking care of the coefficients, negative 5. Okay, so you have dividing all the terms out by this value. Okay, so negative 5y over negative 5. Okay, so this will become y. And for negative x over negative 5, negative over negative is a positive. And x over 5, you can just write this as 1/5 of x. And then 1 over negative 5, then we have minus 1/5. So for the given line, the slope is at 1/5. Okay, now for the parallel line. And this one, okay. So parallel lines are going to have the same slope. Okay, so the slope is going to be at 1/5. And now for the parallel line, okay, that's going to go through the ordered pair, which in this case is going to be 6, -4. Okay. And so just getting things set up. Okay, so we have through the point slope equation substitution. Okay, so you got y minus y of 1, which is going to be y minus -4. And we have the slope m again for the parallel. Okay, that's going to be at 1/5. And we have times the quantity of x minus 6. And here we have y minus -4. Again, just undoing the double negative, so we're going to have y plus 4. And 1/5 over the quantity of x minus 6. So we have 1/5 of x minus 6/5. And getting y by itself. Upon taking 4 away from both sides, so we have the y is equal to 1/5 of x. And for -6/5 minus 4, think of like -6/5 minus 4 over 1. And if I multiply 4 over 1 by 1 in the form of 5/5, we'll have -20 over 5. And -6/5 and a -20/5, this will be a -26/5. And so we have for the slope-intercept equation of the parallel line, we have y is equal to 1/5 of x minus 26/5. And for establishing what we have for the perpendicular line, and again, perpendicular lines will have opposite sign reciprocal slopes. So the given line has a slope of 1/5 for the perpendicular. Okay, so we're going from a positive to a negative, and the reciprocal of 1/5 is going to be at 5. Okay, so the slope we have at -5 for the perpendicular. Again, so you have 1/5 times -5. So you have -5/5, which is -1. Again, just reaffirming that the product of perpendicular line slopes is -1. And again, so we have the ordered pair through which the perpendicular line passes. Okay, again, it's also 6, -4. And for the point slope route, okay, again, we have the same x01, y01, and the initial difference this time around is with m. So for y minus y01, again, we have y minus -4. We have is equal to the slope m, which we have at -5. And we have times the quantity of x minus 6. So again, we have y plus 4, and with the distribution of -5 over the quantity of x minus 6, we'll have a -5x, followed by where we have negative 5 times negative 6, so this would be a positive 30. And getting the y by itself. And we have, upon deducting 4 on both sides, so we're going to have that y is equal to negative 5x plus 26. And we just mentioned, okay, so for the parallel line, you got this equation. And you can do kind of a quick test on this one. Okay, here we have y at negative 4 and x at 6, and just filling in. 1/5 times 6 is 6/5, and 6/5 minus 26/5 is going to be where you have 6 minus 26 is negative 20, divided by 5, negative 20/5 becomes negative 4, which we have for y. And as for y is equal to negative 5x plus 26, okay, so x is at 6, negative 5 times 6 is negative 30, negative 30 plus 26 is minus 4, which we have for the corresponding y value. Okay, so those equations do check out. And we have, in the same vein, we have in the case of 40, and this time around we have for the given line, okay, we have x minus 2y is equal to 7. And if we look at configuring, okay, what the slope of this line is going to be, okay, so you have x minus 2y is equal to 7, and getting the y term by itself. Okay, so again, I can move the x over by subtracting. So we have that negative 2y is equal to negative x plus 7. And upon division by negative 2, okay, so we got y is equal to, and for negative x over negative 2, negative over a negative is a positive, so we got 1/2 of x, and 7 over negative 2, so this will be minus 7/2. And so in the slope-intercept form, okay, it turns out that the slope is going to end up at 1/2. And for what we have in the case of the parallel line, so the slope is also at 1/2. And the point through which this is going to be passing, okay, this will consist of the coordinates, okay, where we have 5, 4. And setting things up once again. Okay, so y minus y1 is equal to the slope m times the quantity of x minus x01. So for y minus y01, okay, so we have y minus 4, and the slope m, which is going to be at 1/2, and we have times the quantity of x minus 5. Okay, so we got y minus 4, and distributing 1/2 over the quantity of x minus 5. So we have 1/2 of x minus 5/2, and getting y by itself. And we have, upon adding 4 to both sides, so we got y is equal to 1/2 of x. Now for negative 5/2 plus 4, or 4 over 1, okay. So for the exact result, okay, so just making both of these into halves, so we got negative 5 halves, and 4 over 1 is going to be 8 halves. And we have negative 5 halves plus 8 halves is going to come out to 3 halves. And so for what we have here for the slope-intercept form, we have y is equal to 1/2 of x plus 3 halves. And once again, you can test the result. Okay, so at x at 5, half of 5 is 5 halves. 5 halves plus 3 halves is 8 halves, which will go to 4, and that is automatically the value that we have in y. So we have 4 is equal to 4. And for what we have in the case of the perpendicular line, okay, so for the given line, the slope is at 1/2, and for the perpendicular, okay, the opposite side reciprocal of 1/2 is going to be at -2. And we're still using the same point through which we had the parallel line to pass. Okay, so we'll apply this for the perpendicular. And just setting things up. Through the point slope route, okay, so I have y minus y of 1 is equal to the slope m times the quantity of x minus x of 1. So for y minus y of 1, okay, so that's going to be y minus 4 is equal to m, which we have at -2. And we have times the quantity of x minus 5. So we got the point slope equation. And delving further, to get to the slope-intercept equation, so we got distribution on the right. We're going to have -2x plus 10. And for isolating y, again, we have the addition of 4 at both ends. And so we're going to have here that y is equal to -2x, and 10 plus 4 is 14. And we can check. So with x at 5, -2 times 5 is -10. -10 plus 14 is 4. And the left-hand side of the equation is y, which is also at 4. So the left and the right-hand sides have equal numerical values. Okay, so this equation works for the given slope as well as the point through which the perpendicular line is going to pass. All right, now from the other day, okay, I had touched briefly upon piecewise defined functions. Again, piecewise defined functions, okay, have like taking a function and breaking it up into different capacities or brackets or categories. And in the case of piecewise defined functions, and let's say we have just as a case of a function, and we'll say we have f of x is equal to x squared if we have x to be less than -3. Now for other values, okay, we might have f of x equal to x cubed. If we have it such that negative 3 is less than or equal to x is less than 4. And just kind of rounding out the rest of the entire real number system. Okay, say as a third possibility, okay, we have that f of x is equal to 7 if we have that 4 is less than or equal to x, which in turn is less than or equal to 8. And then we have, as remaining category, we'll have that f of x is equal to x minus 5. If x is greater than 8. Okay. Alright, so we have again x squared if x is less than 3. So you have like negative 3 on down, but you have picking up with negative 3 for the next part, but leaving out 4. And we have 4 in the mix going out to 8. And then we have rounding out for values of x greater than 8. We have the function equal to not y minus 5, but x minus 5. Okay, say if we were to determine the following. And say we have first of all, okay, we'll go with let's say we have f of 2. And say we have f of 10 and f of negative 1. Okay, so for what we have here, so again, your input values have a 2, 10, and negative 1, and the input variable is going to be at x. And in terms of which of the 4 functions we're going to use for the respective input values. So for f of 2, okay, if you notice, okay, 2 is not greater than 8, 2 is not between 4 and 8, and 2 would not be less than negative 3, but 2 is between negative 3 and 4. So we have like first instance, so we have negative 3 is less than or equal to 2, which in turn is less than 4. So this is going to be a true statement, okay, because negative 3 is less than 2 to begin with, and 2 in turn is already less than 4. So with this corresponding description, we go with the x cubed pathway, okay, with 2 as the x value. So for f of 2, okay, it's going to be 2 to the third power, and 2 to the third power is 2 times 2 times 2. Okay, so that will end up at 8. Now, if you have the input value at 10, and guess what? 10 is not less than negative 3. It doesn't fall between negative 3 and 4, nor does it fall between 4 and 8. But it does fit the bill of being greater than 8. So you have 10 is greater than 8. So we go with x is greater than 8 route. And for those input values, okay, we go with the function where we have f of the input is equal to the input minus 5. And so that input we have at 10. Take away 5. So f of 10 is going to be equal to 5. And for f of negative 1, for f of negative 1, okay, yeah, doesn't belong here nor here. But negative 1 does fall between negative 3 and 4, just like the number 2 did. Okay, so to say that negative 3 is less than or equal to negative 1, in turn is less than 4, that's going to be true. And so with the negative 1, just like 2, we're going to give it the cubic treatment. So f of negative 1 is equal to negative 1 to the third. And negative 1 cubed comes out to minus 1. Alright, and tell you what, just with what we have with the piecewise defined function, say for the next few moments. Okay, let's see what we get for f of -3, f of 4, let's see, we have f of 7.99, f of 8, and also f of 8.01. Okay, so just for the next few moments, okay, let's see what function values we get for these respective inputs. Okay. For what we have in terms of categorizing, okay, in terms of how to set this up, okay, so you got your input values. Okay, so we have f of -3. Okay, notice we have -3 appears twice among the brackets here. Okay, and in terms of where -3 belongs, well, -3 cannot be less than itself, so we're not going to use x squared. And again, we have -3 in the second inequality statement. So while -3 cannot be less than itself, we do have the equal sign. So we do have that -3 can be equal to itself. And -3 in turn is going to be less than 4. So instead of going with x squared, we're going to go with the cubic function. So with x at -3, x cubed is going to translate to -3 cubed. And -3 cubed is going to be at -27. Okay, now for the input at 4, okay, just like -3, 4 appears twice. And again, now -3 is less than 4, or less than or equal to 4. So that first half is true. But the deal breaker is trying to say that 4 is less than itself, which it is not. Okay, so the second inequality is disqualified. Now for the third one, now we do have, now 4 cannot be less than itself, but it is equal. So 4 is less than or equal to 4, thanks to the equal sign. That part is true. And in turn, okay, now we have 4 is less than, to say that 4 is less than or equal to 8, that is also true. So we use this third inequality, okay, and so 4 belongs in the third description, and for the value or expression that corresponds for f of x, okay, it's going to turn out that f of 4 is equal to just 7. And for what we have in the case of f of 7.99, okay, well, in this case, okay, we have almost tangent to 8, and 7.99 is not greater than 8, but it is between 4 and 8. So you have that bit of history to repeat. So just like 4, 7.99, okay, is between 4 and 8. And once again, anything that falls between 4 and 8 inclusively, the corresponding y value is going to be at 7. So you had that part to repeat. And for f of 8, okay, again, had the same kind of run-in. Okay, now 8 is not greater than itself, but it is equal. So to say that 4 is less than or equal to 8, it is less than, so that is true. And 8 is less than or equal to 8, not less than itself, but it is nonetheless equal. And so in this case, it turns out we have kind of a hat trick, as in 3 in a row. So we have that f of 8, just like f of 4 and f of 7.99. Okay, this also lands at the y value of 7. And for f of 8.01, okay, 8.01, okay, so we have, just like the number 10 from earlier, okay, that is greater than 8. And so in terms of which of the 4 types of functions, well, it's going to be in the last case. All right, so with x minus 5 and x at 8.01, we have 8.01 minus 5. And so the final output, okay, this will be the decimal value of 3.0 0, 1. All right, so we've been looking at pretty much functions on an individual basis. Okay, and now looking at, say, if we have interaction between functions that are distinct from each other. And so we have for the next case, all right, we're going to have what will be regarded as operations between functions. Okay, and you can have functions designated in various capacities, just different ways of labeling. Okay, but we'll say that just for good general cases, we'll just designate the functions as f of x and g of x. Now, there are different operations involved. We'll start out with the common four, where we have just the multiplication, addition, subtraction, as well as division. Okay, and we'll start out with what's referred to as the sum function. And the shorthand notation of this, you have f plus g of x. So you got the sum function. And translating this, okay, that's going to come out as the sum of the functions f of x and g of x. Then we have next, okay, we have the difference function. Difference where we have subtraction involved. And we have for the difference function f minus g of x. This can be written as the difference of functions. We have f of x minus g of x. Right, and one might ask, could it be the other way around, like g of x plus f of x, or g of x minus f of x? And the answer to that is yes, if you have g out in front of the f in these cases, like g plus f of x and g minus f of x. And in the case of the product function, for f times g of x. So this will become f of x times g of x. And then we have what is regarded as the quotient function. And that concerns the operation of division. So if I have f over g of x, this will translate to the quotient as you divide f of x by g of x. Okay. All right, so you had the sum function leading to the sum of functions, difference function to the difference between functions, and again you have the product function equal to the product of the individual functions f of x and g of x. And for the quotient function, we're looking at the quotient between the functions f of x and g of x, where we have f of x divided by g of x. All right, now we'll be looking into just the basic examples where we have these operations concerned, but we're going to be looking into domain for operations between functions. And I just want to mention for the first three operations, for the sum, difference, and product functions, So these first three functions will all have the exact same domain. And okay, now their domain, okay, this is going to be formed by combining restrictions, if any. Of f of x and g of x. Okay, what I mean by this, okay, now if there are no limitations to f of x or g of x, okay, if there are no limitations at all or any restrictions at all, like the domain of f of x would be all real numbers, that of g of x would be all real numbers, and that would roll over to the sum, difference, and product functions, where you would have the set of all real numbers throughout. But if there are any limitations to f of x or g of x, those limitations will carry out to the sum, difference, and product functions, and they'll also be imposed also for the quotient function. But now, for what we have in the case of the quotient function, okay, for f over g of x, okay, not that it will, but it can possibly have a different domain. And the reason it can possibly have a different domain is because while g of x can be 0 for the sum, difference, and product functions, it cannot be in the quotient function. Okay. So these are just future references here. So the sum, difference, and product functions will have the same domain, and again for the quotient function, because the way it is set up with g of x on the bottom and as a fraction, and the only fraction that we have among these four operations, again, we have restricted that g of x cannot be 0, whereas it could be with the other three operations. Okay, so after giving this advance, okay, just to give you kind of a view in terms of operations between functions. See, we have given f of x is equal to 3x plus 7 and g of x, okay, is equal to 4x minus 3 and we were to determine the following. Okay, so we have first of all, okay, let's say we have just for the sum function, okay, so we have it laid out as f plus g of x. Okay, and again we have with f plus g of x, we got the sum function. In this case, the sum function f plus g of x once again translates to the sum of the functions f of x and g of x. So we have for f of x, okay, what is f of x? Well, f of x is at 3x plus 7. And g of x, okay, that is at 4x minus 3. And I'm just using parentheses just to just separate the f of x from the g of x. And just looking at removing parentheses, okay, and so by then you can get to the final result. So there are going to be no sign changes. And for what we have upon combining the terms, so you have 3x plus 4x. So it'll be 7x, and 7 plus 3 comes out, in this case, or I should say 4x minus 3. My bad. So you got 3x plus 7 plus 4x minus 3. Okay, so you got 3x plus 4x is 7x. 7 minus 3 comes out to 4. Okay, now for what we have in the case of f minus g of x, okay, so we have an f minus g of x. We have the difference function. And again, this will be expanded as the difference between the functions f of x and g of x. Okay, so you have with f of x, okay, so I have 3x plus 7. I have subtracting g of x, okay, which I have at 4x minus 3. Again, I'm using parentheses to distinguish and separate, or distinguish between and separate the f of x and the g of x. Okay, so removing the parentheses, all right, so we have 3x plus 7 all over again. But with g of x being subtracted, all of 4x minus 3 is going to have the terms to change signs. So we have minus 4x, and subtraction over minus 3, that would change over to the addition of 3. And for the result here, we have 3x minus 4x becomes negative x, and 7 plus 3 is 10. And just a quick reverse order scenario. If I'm looking at what's going to result from the difference function where I have g minus f of x. Okay, so that's going to be g of x minus f of x, and for g of x, we have 4x minus 3. And subtracting, now we have with f of x, 3x plus 7. Okay, so we're trading places in terms of what comes at the front and what follows. So removing the parentheses this time around. So we have 4x minus 3. And it is now 3x plus 7 that will have the terms to change signs. So we have a negative 3x and a negative 7. So we got 4x minus 3x becomes x. Negative 3 minus 7 becomes negative 10. And just between f of x and g of x. Now if we're looking for the resulting product function for f times g of x, for f times g of x, okay, so we'll have f of x times g of x. Okay, so f of x again is going to be at 3x plus 7 And g of x, okay, we have it 4x minus 3. And if we FOIL the terms out, so we got 3x times 4x, so this will make 12x squared. Outside product, okay, we have it negative 9x. Inside product, we have 7 times 4x. So we have 28x, and then we have 7 times negative 3 is a negative 21. And combining the middle two terms, so we end up with the trinomial, whereupon we have 12x squared plus 19x minus 21. Okay, and just taking what we have in terms of the quotient function. Sometimes there might be more steps involved, and other times it might be just less work than what many would otherwise anticipate. Now for f over g of x, okay, so we have, again, just translating as a quotient of functions, we have f of x over g of x. And here, f of x, we have at 3x plus 7. And g of x, okay, we have 4x minus 3. Okay, so there's no factorial relation between f of x and g of x. Okay, okay, so 3x plus 7 is its own factor, and there's nothing about 3x plus 7 that is a factor of 4x minus 3, and vice versa. So just a mere substitution, okay, gets us to the complete result for that one. And just to kind of mention too, if I had it the other way around, okay, where I have g over f of x okay, so g is at the top, f is on the bottom. Okay, so this will be g of x over f of x, and g of x, okay, so we'll have it 4x minus 3, and for f of x, okay, so that is going to be at 3x plus 7. All right, so these are instances of what we have for operations between functions, and the operations are not necessarily limited to just two functions, but for this part, okay, we have just interaction between two functions. Okay, that is a common and often useful heuristic whenever we just limit to two functions.